Today I have chosen a very important topic as it is used in solving complex problems. Doesn't matter how much noisy our data is, backpropagation playing vital role to find out an unrecognized pattern. So it is highly recommendable algorithm proven in medical field. As a brain tumor is the biggest application of the backpropagation, we can say, although it take long time for training and less interpretable. Now let's talk a little bit about how backpropagation helps in finding out tumors. So the method of neural network is used to identify brain images. A statistical feature extracted from GCLM and angles are used as input data, whereas normal and tumors brain images are used as target data. And for training, they are having bulk of tumored images already present in our data set. Alright, so let's start understanding first what is in detail. So basically, what is backpropagation we must have to know first. So a backpropagation is a deep learning algorithm used in machine learning to train neural network of a model in supervised learning with backpropaganda. In general, it's utilized to train gradient descent of error in simple or complex algorithm. In deep learning, to find the errors more accurately than others. As we are seeing in the figure, there's an input, hidden layer, and output and reverse direction arrow, right? How does forward pass work? In forward pass, initially the input fed into the input layer. Since the input and the raw data, they can be used for training our neural network, right? The input and their corresponding weights are passed to the hidden layers in neural network. For instance, consider illustration figure. There are two hidden layers and output of H1 can be used input of the H2, right? Before applying activation function, the bias is added. So the weighted sum of the inputs, the activation function applied in the hidden layer to each of its neurons. One such activation commonly used is ReLU can also be used, which is responsible for returning the positive input, otherwise returns 0. Alright, so by doing this, so it introduces the nonlinearity to our model, okay, which enable the network to learn complex relationship inside data. With the help of heat map or visualization techniques, we can also visualize it. And finally, the weighted outputs from the last hidden layer were fed into output to complete to find the prediction. And this layer can also use the activation function softmax, which is responsible for converting the weighted output into probabilities for each class. Alright, or in backward, what we need to do as we are getting errors, so we'll go backward to sort out the error, which helps the network to improve its performance via learning rate and adjusting the performance of the weights and bias. So we have to go backward, use the prior weights and bias and update there, and this process will be repeated until we achieve our target. So for that reason we will use the MSE, that is mean square error, which calculate the difference between the predicted and desired output. Alright, so MSE is equal to y minus y hat whole square. That is our loss function, we can say mean square error, right? So we have to reduce the loss as an error, right? Now if we look at the figure, there's weight, W, B bias and Y hat is a prediction value, or we can say estimated value of dependent variable. So let's take a general example, like we are in an institute and our instructor assigns some project in our team. As we work our project as a team, so on that basis of project grade, team will be selected for the higher package. Okay, so we have team 1, team 2, team 3 as you're seeing in the figure, and so on. Then grade for team 1 is 7.5, then got 5 plus pay package, and the team 2 having grade 6 will get 4 plus PA. Now if we look at team 3, grade 8, right, of 10 will get 3 plus PA. On the other hand, team 6 also having a grade and receiving 25 plus PA. Great. So this shows there must be some error. So for team 1, our predicted value is coming 22 plus LPA. Like from training data set, the prediction has come. We are not going in the process how it come. We are just considering. Alright. So let's see. Here we have to take some steps. So it's in step 0, initialize weight and biases. We have to initialize, then we select a point or row. There we will activate our nodes and we'll use linear function. So what is our role here? That is initial value of weight and bias whom we use to predict that the student in LPA will be, that is called forward propagation. That is dot product. Initially the weight is ridiculous, which results anything like randomly occurrences of output, we can say. So let it number be 22 plus LPA for a moment. In actual the data is 5. Since we start with the wrong weight, so the resultant will be the 22 plus LPA. Although we solve, but here our motto is to understand backpropagation. No need to exaggerate it. Now let's come to the point. Actual data is 5 lakh, but our neural network saying it should pack 22 plus RPA. So know clearly that they are having some mistakes. So why it is happening? Because our weights and biases are not correct. For that reason, we need to find out error, and on the basis of the error, we have to adjust our weights and biases. Now in step 3, we have to choose a loss function. It's a regression problem. We'll use MSE, that is mean square error. So L is equal to y minus y hat whole square. So 5 minus 22 whole square is equal to 29 as showing in the figure. That we can say error residual. So now what we have to do, we need to use this error and need to confide our neural network. Look, you are doing blunders. Now you have to adjust your weight and bias and to resolve this error occurrence problem. Alright, now just think about it, how it will work here. Let's see the figure properly. You can see what is loss here, that y minus y hat whole square. So basically there are two components in the loss function, that is y or y hat, right? So neural network prediction, that is 22. Now we have to decrease the loss, we need to reduce error, right? So if we talk about our loss function, that is y minus y hat whole square, that is mean square error. So we have to reduce the loss as an error. I can't change y because it is in our data set. So we will change y hat. In this case, my y hat is 22. Right? Also possible my y hat is then we need to increase it, right? Now the question arises, y hat increment or decrement depends on which factor. If you see neural network, then you can understand easily y hat is basically the output from the O21. How O21 calculate this neuron having 5 things. This weight will multiply with the output, that is equal to O21 is equal to W211 O11 plus W221 O12 plus bias, that is B21. Alright. Since here is no activation function sigma z, so we are not adding it. Right? Y hat is depends on 5 things. That is O11, W211, W221, B21 and O12. Alright. So if I can make a chart, then how it look like? So if we look at the figure, then it looks exactly like this, right? Now see carefully that what our chart is describing or trying to describe it. We need to change L. For that we change Y hat, whom we can say O to 1, and this thing depends upon 5 things. And what is this? That is O11, O12, W211, W21, 21, B1. Alright, if we talk about bias and weights, then we can easily change it, right? But if we talk about O12 and O21, basically talk about O11, then it is also depends upon 5 things. That is B11, team, grade, W111 and W121. Right? Similarly, about O12 depends on which factor. So this is the question for you. Just write the answers in the comment box. Right? So if you see, it's a complex hierarchy, right? If we have to look at the loss function, loss to minimize, for that reason we need to change y hat is equal to O1. So if we can change this thing, then we change all 5 things, right? In which O12 and O11 is sub complex things. To change it, we have to go more backward and have to do changes prior, because we can't change team and grade, right? Because that is in our data set, so we can't change it, but we can change other weights and biases, right? So the idea is very simple, that this loss to reduce depends on how we update the prior weights and biases by going backward, right? And the way going backward and doing changes in weights and bias, that's why this algorithm name the backward propagation. I hope the concept is clear here. So step 4, we need to update our weights and bias by using gradient descent. So we need to apply this rule as you are seeing in the figure. Now if we look at the figure, we have four formulas. They are W new, B new, W211 new, then W221 new, then B21 new. 5 formulas we have to use. So what first one is W new, that is equal to W old minus eta del L over del W old, right? Then if we talk about B new, that is by so B old minus eta del L over del B old. Now third one is W211 new, that is W211 old minus eta del L over W211, right? Now fourth one is W221 new, that is equal to W221 old minus eta del L over del W221. Alright, then fifth one B21 new is equal to B21 old minus eta del L over del B21. Now guess what? What if we focus on the W2 old 11 old? So it is equal to the 1 because this value we have already present, and I'll have learning rate that is 0.1. Generally we take, alright. Now I have to find only del L over del W211. Alright. Then I don't have right. So what's this term? That del L over del W211 that I don't have. This is the derivative of loss function with respect to particular weight, and I have to find, and everything depends upon it. Okay, so if we go back to the definition, then if you read, you can understand. Given an artificial neural network and an error function, and our error is mean square error, right? Then the method calculates the gradient, that is our partial derivatives with respect to neural network y. Look, we are doing the same thing, right? See, whom we have saying gradient here. Gradient is partial derivative, so we are calculating the gradient del L over del W. So our loss function is whom derivatives we are finding out with respect to all the weights present in our neural network. Alright, I hope you are getting my point. Now in short, what we need to do, we have to find out 9 derivatives, or if find out all those 9 derivatives, then our algorithm will be complete and it will start working. Alright, so in the next I will show you how to calculate it. I'm summarizing this thing. Initial, what we have to do, we'll choose some random value, then we'll take one by one theme, and I took first theme that did the prediction for that theme via forward propagation. We get one number. Now we took that number in the loss function and it find error for that point. Now as it calculate error and we find out the error, what we have to do, we just go backward or in reverse direction. In our neural network, and we need updation, do some kind of changes, prior bias and biases to get higher accuracy, right? And how that updation will take place, so by using this formula it will happen. All right, so if we look at the definition of backpropagation, it is an algorithm for supervised learning of artificial neural networks using gradient descent, right? Given an artificial neural network and error function, the method calculates the gradient of the error function with respect to the neural network weights. So look whom we said gradient. Gradient is said to be a partial derivative, so we are calculating the gradient of error function. And our that loss function whom we are finding derivatives with respect to the all the ways. Alright, I hope you are getting my point. So in short, what you have to do, those 9 derivatives that only we need to calculate, because all other function we have like learning rate eta, if I find the value of derivative, then it will start working, right? So here we have to calculate our 9 derivatives, right? that first step we can say del L over del W2 1 1, del L over del W2 2 1, and then del L over del B 2 1. This is the first three. Then second, del L over del W1 1 1, comma del L over del W1 2 1, comma del L over del B 1 1. This is the second step we have to find out, and the third one is del L over del W1 2, del L over del W2 2, and then del L over del B1 2. As you're seeing the diagram, we have team and grace, weights and biases. Y hat is equal to loss. Then here we need to find all the 9 parameters with respect to loss function derivatives. Alright, so we'll start with the first set, that is look these derivatives. Will find out. It's not difficult task, right, as it is a mathematics, right? But I want to give you intuition that you guys need to understand that we have to minimize our loss function, and L depends on y hat and y hat depends upon the W211. Then why we are finding derivatives of this, what we are getting from this quantity, that we need to understand, right? Look what is happening, you have to understand. As you're seeing the figure also, that we have y-axis, x-axis, and there's a one slope, then it is look like some kind of hyperbola kind. That from the first principle we have to find the derivatives, that is dy over dx. That also we call slope, as we have already learned in mathematics. Whenever we are finding out dy over dx, so what does that means? It's a slope. You can see graphically, y is one quantity and x is another quantity, and we need to find what a little change occur in x, then what changes arises in y, right? As you see graphically that plot, this is a slope. These things you have learned in mathematics, right? Now here del L over del W211, if I'm doing little changes in W211, just listen carefully here, that what does del L over del W211 means. If we are doing little changes in W211, then what changes arises in L, right? That thing I guess you have understood. But if you understand this change, that you will see W211 is not directly related to loss, means its direct change will not reflect here. Means if we do some changes in W211, then our y hat will change, and when y hat will change, then some changes also reflect on the loss, right? You can't directly find out del L until you will find del L over del y hat. So that is multiplied by the del W211, and then multiply del y hat over del W211. So our formula is here that del L over, I think next. Now if we look at the formula, that del L over del W211 is equal to del L over del y hat multiplied by del y hat over del W211. This is said to be chain rule of differentiation. Alright. Del L over del y hat is equal to del over del y hat multiplied by y minus y hat. So the resultant is minus 2y minus y hat. Alright. This is we are getting after differentiating it. Del y hat over del W211 is equal to del over del W211. So inside the square bracket O11 multiplied by W211 plus O12 multiplied by W221 plus B21. So if we are differentiating W211, right, with respect to W211 this figure inside the square. Then you can see where is 11 in the base, and we can see in only one item here, and the next one there is O12 and W21 will become 0, B21 become 0. Alright, this is the differentiation rule as you see in the figure. This differentiation is very easy as del W211 is only having one term, that is O11 and W211. Other term will be 0 as the resultant. So what we are getting here, del over del W211 inside the square bracket O11 W211. So the resultant will be O11. That W211 will cancel and gives 1 after differentiating. So O11 is the resultant. Now, going by this logic, we can write del L over del W211 is equal to minus 2y minus y hat multiplied by O11, and this is our first equation. Right? First thing we have already calculated. If you'll understand here, then it is very simple. L depends upon y hat and y hat depends upon 5 things. W2 to 1. Then again write chain rule and find del L over del W2 to 1 is equal to del L over del y hat multiplied by del y hat over del W2 to 1. So if you notice that del L over del y hat, that is common on both the equation, and we have the del L over del y hat value, so we need to find out the only del y hat over del W2 to 1. Okay, now del W y hat over del Y2 to 1 is equal to del W2 to 1 multiplied by the inside the square bracket O11 multiplied by W211 plus O12 multiplied by W221 plus B21, that is our bias. So what is the resultant? That is O12 resultant, as W21 is in the base of that differentiation. So what we are getting, the equation second, del L over del W21 2 to 1 is equal to minus 2 multiplied by y minus y hat and O12, right? Now we are finding second equation also. Now we have to find for bias, same rule will apply for bias loss, depends on y hat and y hat depends on b. I guess you are noticing the pattern now. Del L over del B21 is equal to 2L del L over del y hat multiplied by del y hat over del B21. So del y hat over del B21 is equal to 1. By going this logic, we find del L over del B21 is equal to minus 2 times y minus y hat. This is our bias and third equation. So if we find the first set, if you see, alright. Now come to the step 2. As we are seeing, y hat depends upon loss function, and here y hat depends upon 5 things and y hat depends upon O11. So as chain is making here, O11 depends on y hat depends upon loss function, or if we go forward then L tends to y and y tends to O11, right? Or you have O12. So each have 5 factors, that O11 also have 5 factors. So if we go reverse direction, then it will become back propagation, that from O11 to y hat. If we are do some changes on O11, then voltage change will come to the y hat, and then L will also change, right? So let's come to the formulas, that del L over del W11 is equal to del L over del y hat over del O11 and del O11 over del W11. So here are first two things in the all three equations are common, right? And the second one also del L over del W1 2 1, del L over del Y hat multiplied by del Y hat over del O11, and then del O11 over del W2 1. So in all three, del L over del Y hat multiplied by del Y hat over del O11. These are common in three. So what we need to find others, the rest of. O12 also depends upon five things at O11. So del L over del W1 12 is equal to del L over del Y hat multiplied by del Y hat over del O12 multiplied by del O12 over del W1 12. So right, then del L over del W1 2 is equal to del L over del Y hat multiplied by del Y hat over del O12, then multiplied by del O12 over del 1 W1 2. Then what is bias here? Del L over del V12 is equal to del L over del Y hat multiplied by del Y hat over del O12 multiplied by del O12 del B12. Alright. So if we focus on then how many derivatives you have to find out, del L over del Y hat, and it is present in others too, and value we have already found, so it's done. Now second, what we have to do, we have to find out the del Y hat over del O11, that is equal to question mark, you are seeing in the figure. So three thing we have to find out, that del O11 over del W121, del O11 over del B11. Then third term is del O11 over del W111. These three items we have to find out. Right. Yeah, it has written formula above. Del Y hat over del O11 is equal to del over del O11. Inside the square bracket, like before, W2 11 multiplied by O11 plus W2 21 multiplied by O21 plus B21. So we are differentiating it, the rest will be the 0 where O11 is not present, so only in the first term O11 present with the W211. So the resultant will be W211 as you see. Similarly, del Y over del O12 will do the same thing. Alright, and what we are getting, W221. Now next, del O11 over del W111. That is team time W111 plus grade time, grade multiplied by W121 plus bias we have here B11. When differentiated, then other value will be 0. Alright. So what we are getting, less. As you are seeing in the figure, that xi1 we are giving it for not confusing it, not making it difficult, we are giving this ith term, that I is equal to rho in the theme in the grade, then O11. Similarly, when we find next terms, that del O11 over del W121 is equal to xi2, that del O11 over del B11 is equal to 1. Alright, then del O12 over del W112 is equal to del over del W112. Inside the square bracket, team W112 plus grade W122 plus B12. Alright, now after differentiating, what we are getting, we are del W112 terms present, that will be differentiated and other rest will be 0. So that is equal to team of xi1, that del O12 over del W112 is equal to team of xi1. Alright, and now next one, del O12 over del B12 is equal to 1. Now you can see all the derivatives in the figure. What we are getting, del O11 over del W1 is equal to minus 2 times of y minus y hat multiplied by W2 xi1. This is the first term. Here in the step 2, del O11 over del W1 is equal to minus 2 times of y minus y hat multiplied by W2 multiplied by xi2. Then the third term is del O11 over del B11 is equal to minus 2 times of y minus y hat multiplied by W2 These are the second three terms we are getting, and the third three terms. These all remains three answers. Alright, similarly we have to do, remember this, del y hat over del O12 is equal to W2 So other values will be del O12 over del W1 is equal to minus 2 times of y minus y hat W2 multiplied by I1. Second term is del O12 over del W1 is equal to minus 2 times of y minus y hat W2 multiplied by xi2. Then third term will be del O12 over del B12 is equal to minus 2 times of y minus y hat multiplied by W2 So finally we find out all the 9 trainable parameters here. I solved this because I want to my folk to understand the pattern. These all our 9 derivatives. If you analyze all those formulas, then you can easily apply it on the algorithm, right? Now we will use the values and find out the solution of our query. Alright, now we learn to calculate derivatives. It's time to apply it on our data set for backpropagation, and we have 9 trainable parameters. So let's summarize the things a little bit. Initially what we have to do, so step we will give value to all weights and biases, 0 weights and biases in it, initialize all this randomly, weight is equal to 1 and bias is equal to 0. It is a simple way to initialize. Alright, in step 1 we run a loop, so how many times we repeat the process, it depends upon how many number of data in our data set. Means we are iterating the process, right? And like from epochs we are giving the values. So in the next step, one student will do forward propagation, then prediction, then they get packaged, then we do prediction and salary predictions, right? Then we will calculate the loss function by using MSE, then adjust all weights and biases, and on the basis of loss we will adjust our base and bias, right? It all depends upon target value, then how many number of iteration we have to do so that we will achieve our target value. And what is the formula to adjust this gradient? Gradient is said that is W nu is equal to W old minus eta del L over W del W old. Iterate this process until we reach target. What happening? We will adjust weights and biases in every situation so that it will slowly reach the target value. That loop may be 10 times, 20 times, or maybe 100 times sometimes. Y minus y hat, this iterative method of updation of values in each epoch said to be backpropagation. Okay, so I hope everything is clear.